Hello viewers, in today's session we are going to discuss another important and conceptual problem from linear differential equations, right? So viewers, we have already discussed a lot about linear differential equations in our earlier discussions, and in this session we are going to discuss this problem where we have to find the equation of the curve passing through the point pi by 4 comma 1 and having slope 2 sine 2x over x cube minus 3y over x at each point, that is x comma y, with x not equal to 0, right? So here we have to obtain the equation of a curve whose slope is given as 2 sine 2x over x cube minus 3y over x, and here in order to find out the equation of the curve, we'll make use of the concept of linear differential equations of the type that is dy over dx plus py is equal to q, right? So we have already discussed these type of equations, and when we have a linear differential equation of first order and first degree of this form, dy over dx plus py is equal to q, where p and q are functions of x, or p or q may be some constants, then in order to solve these kind of equations, we make use of the concept of integrating factor, right? So the integrating factor of this type of equation is given by e raised to integral p dx, and the solution of this type of linear differential equation is given by y times integrating factor, that is if, and then we have integral q times integrating factor, and c is the constant of integration, right? So these two important concepts are there. First we have to find out the integrating factor, which is equal to e raised to integral p dx, and then the solution of this equation is given by y times integrating factor is equal to the integral q times integrating factor plus c, right? So let us see how we can transform this problem into this type of linear differential equation. So now in this problem we are given that the slope is given by this expression, right? And from calculus we know that if we have a function or a curve, say y is equal to f of x, which is defined in some domain say d, then the slope of the tangent is given by dy over dx, right? So the derivative of y with respect to x at each point of the domain d gives us the slope of the tangent to the curve at that particular point. So dy over dx is the slope of the tangent, which is sometimes also denoted by the letter small m, right? So dy over dx is given as this expression, that is 2 sine 2x divided by x cube minus 3y over x, and obviously here x is not equal to 0. So now let us take this term, that is minus 3y over x, to the left hand side, right? So we have here dy over dx plus 3 over xy, and here we have 2 sine 2x over x cube, right? Now we can easily see that this equation is similar to this one, that is dy over dx plus py is equal to q. So now if we compare these two equations, we can easily see that p is equal to 3 over x, and p is a function of x, and q is given by 2 sine 2x over x cube, right? So in order to solve this linear differential equation, we have to find out the integrating factor. So the integrating factor is given by e raised to integral p dx. Now p is 3 over x, and here we have dx. So let us solve this integral. We can take 3 outside the integral. We have dx over x. Now the integral dx over x is simply the natural log of x, or we can also write it as the log of x to the base e, right? So we'll prefer this notation. So here we have e raised to 3 times log of x, right? So from the properties of logarithms, we can write e raised to log, and here we can write x cube. So taking this 3 to the power of x, or the exponent of x, and here we have the base e, right? And from calculus we know that this important relation, that is e raised to log a, is equal to a. So here we have x cube, so here we have x cube, right? So e raised to natural log of x cube is equal to x cube. So our integrating factor is now x cube, right? So now the solution of this differential equation is given by this expression. So we have y times integrating factor, that is simply x cube, and then we have integral q is given by 2 sine 2x divided by x cube multiplied with the integrating factor, that is x cube, and here we have dx plus c. So let us simplify it. So we have y x cube, and here this x cube and this x cube get cancelled. We can take this 2 outside the integral. We have integral sine 2x dx plus c, right? Now the integral, that is sine ax dx, is given by minus 1 over a cosine ax, right? So the integral of sine 2x is given by 1 over 2. Here we have the negative sign, then we have cosine 2x, and c is the constant of integration. Now this 2 and this 2 get cancelled, so we are left with yx cube, and here we have minus cos 2x plus c, right? So this is the general solution of this linear differential equation involving the constant of integration c. So now let us find out the value of this constant of integration c by using the boundary conditions or the initial conditions. So here we are given the point, that is pi by 4 comma 1, right? So we are given x is equal to pi by 4 and y is equal to 1, right? So let us substitute these values in this equation to get the value of c. So here we have 1 times y is 1, and we have pi by 4 raised to 3, and then we have minus cos 2 times pi by 4 plus c. So this is simply pi cube over 64, and here we have 2 times 2 is 4. This is cos pi by 2. Cos pi by 2 is equal to 0, that is cos 90 is 0. So here this term is 0, so we are left with only c, right? So the constant of integration c has this value. So substituting this value over here, we can get the particular solution, that is yx cube is equal to minus cos 2x, and here we have plus pi cube over 64, right? Now taking this negative cos 2x to the left hand side, we have yx cube plus cos 2x is equal to pi cube over 64, right? So this is the required equation of the curve whose slope is given by this expression. We can also write this equation in the form y is equal to f of x by taking x cube in the denominator of the right hand side. So we can also write y is equal to minus cos 2x. Then we have pi cube over 64 divided by x cube, right? So here we have expressed y explicitly in terms of x, that is of the form y is equal to f of x. So this is the required equation of the curve.